Okay, so the next topic that will be covered is expert systems. So this is related to um the knowledge-based systems where we are actually going to put knowledge into the system. So by knowledge we mean things like facts and rules, etc., which all together will form your knowledge base. And using that knowledge base, we can carry out inference and answer questions or make diagnosis and things of that sort. So basically, the expert systems are meant to mimic what the expert does. So whatever the expert does, for example, if you take a doctor who's carrying out a diagnosis, for example, say for infectious diseases or to diagnose whether somebody has cancer, etc. You have all, he has all the facts available, and he also knows that if this is true, then it's likely that he has this, etc. So some rules will be there, and he makes use of these to actually come up with a diagnosis of whether the person has cancer or not, etc. So the idea basically is to take the knowledge which the expert has, which is not only facts. Okay, he has facts, he has rules, but he also has something like some heuristic rules, some rules of thumb which he uses. So take all these from him and put it into the expert system and use the expert system to actually come up with a diagnosis. That's the basic idea of expert systems. So expert system, it's a program which attempts to mimic human expertise by applying the inference method to a specific body of knowledge. So it's the knowledge is specific to a particular domain only. For example, if you are trying to find out whether it is cancer or not, it will only have knowledge about that domain, right? And it will also have things like rules, heuristic rules, etc., which are used to carry out the diagnosis. And the expert system tries to mimic the expertise, the human expertise. Another definition that is given is, it is a system that employs human knowledge captured in a computer to solve problems that ordinarily require human expertise. It's also been said that it's a computer program that reasons using knowledge to solve complex problems. An expert system is a program intended to make reasoned judgments or give assistance in a complex area in which human skills are fallible or scarce. So, suppose humans who are skilled in a particular domain are few, right? You don't get so many people. So if we have a program which carries out the same thing, then it makes sense to use such a program. An expert system is a program designed to solve problems at a level comparable to that of a human expert. So it operates by applying an inference mechanism to a body of specialist expertise represented in the form of knowledge. So these are all different definitions that have been given to what is an expert system. So generally what happened was, like I said in the first introduction, after they thought that AI can be used for everything, they found that it was very difficult to use it, especially it was intractable in many problems, etc. Then they moved over to things like knowledge-based systems, where you can code knowledge into the system and use that knowledge to come up with some inference and come up with answering questions or giving diagnosis, etc. So that's what this expert system basically does. So it tries to model the expert decision making, and there are many application areas, for example, medical diagnosis, computer configuration, machine fault diagnosis, etc. So you find that there are a whole lot of expert systems available, commercial expert systems which were available, which were used for all these different applications. So what you need is, you need a willing expert or a number of experts who will be able to give you that knowledge and help you to code it into your system. And this knowledge will have to be represented as rules, okay? And you make use of these rules to carry out inference and take a decision on what is to be done, basically. So these are some application areas in the field of medicine itself. You find that you have all these areas in which there are expert systems available. Arrhythmia recognition from ECG, coronary heart disease detection, monitoring prescription of restricted use antibiotics, early melanoma diagnosis, gene expression data analysis, in human lymphoma, breast cancer diagnosis. So in the field of medicine, you find that there are a whole lot of applications which are available, basically. Okay, so what are the characteristics of the expert system? First of all, the one important aspect of an expert system is that it can explain its reasoning. For example, if it says that when it gives a diagnosis of cancer in a particular person, it's able to say that it's because of these reasons that we are saying this person has cancer. Okay, so that explanation is very important, especially in the field of medicine, because you cannot make a wrong diagnosis. You have to make a correct diagnosis. So the expert, for example, the doctor can see the explanation and then say, okay, have more confidence in the expert system, basically. So it displays some type of intelligent behavior, and it draws conclusions from complex relationships. Okay, and it provides portable knowledge. What you mean by this is that once you have made the expert system, this can be used anywhere. Okay, so you can use it in a whole lot of different places, right? And it's like using an expert in that particular field in all these areas. And you also have what is known as an expert system shell. So what is an expert system shell? So it already has the inference mechanism built into it. So all you need to do is enter the knowledge part into it, and once you enter the knowledge part into it, it behaves like an expert system and gives you the results that you are asking for. Okay, one such expert system shell is the Prolog language. Okay, so we'll talk about the Prolog language also later. So we have the Prolog. So Prolog already has what is called the backward chaining, where it starts from what you want to know, what you want to prove, right? And it goes backwards and it goes through the knowledge base in a very systematic manner and checks whether whatever the user has asked for is true or not. It's also possible to ask the system to give a value to a variable. Okay. For example, if you have a knowledge base which tells who's the sister of who, brother of who, who's male, who's female, okay, etc. So you could have something like sibling X Jane, and you give this into your Prolog, right, and ask the Prolog to find what are the values that X can take. For example, if Jane has a number of siblings, okay, and your knowledge base gives all those information, it will say X is equal to John, X is equal to Susan, X is equal to Richard, etc. So it gives you all the instantiations that you can get for X. So this is how Prolog works, and Prolog is a expert system shell. So it makes it very easy for a person to just put the knowledge in a particular domain into Prolog and then use it to carry out inference and give you answers to whatever you want. So where should you use expert systems? Okay. It provides a high potential payoff wherever you use it. If you find, for example, that say a number of people who are available as experts in a particular area are very small, then you can use an expert system to do what the experts are basically doing, and it can also reduce the risk. Okay, for example, if you are in high risk areas, for example, where there are in an environment where people cannot go, etc., you can use the expert system to actually carry out some type of diagnosis or take some type of action, etc. So once the human expertise has been captured, okay, and it's put into the expert system actually has that irreplaceable human expertise in it, which is very helpful, okay, and provides expertise needed at a number of locations at the same time, right? So you can use the system which can be used in anywhere. For example, if it is some diagnosis of some cancer or something, you can use it all over the country in different hospitals, right? And also in hostile environments. Okay, so that is something which is important. So it provides expertise that is expensive or rare. Okay, so human expertise is of course it's very expensive if you want to employ a person. Okay, and it develops a solution much faster than the human expert because of the speed of the computers, and it provides expertise needed for training and development so that you can share that expertise with a large number of trainees or large number of other people, right? Okay, so what are the components of this expert system? First of all, the knowledge base. So the knowledge base has all the knowledge which you are putting into the system. So what is this knowledge? It's all the relevant information, data, rules, cases, relationships, etc. So all these are there in your knowledge base, and these are represented, like I said, as facts and rules, right? So facts are everything that is true in the knowledge base, and the rules actually tell you if these are the conditions, if these conditions are true, then maybe the person can be diagnosed with this condition, etc., right? And then you have the inference engine. So what you find is the knowledge base and the inference engine are sort of separated from each other. So the inference engine, it seeks all the information from the knowledge base and then carries out inference and gives answers, predictions, suggestions, etc. Okay, and it makes use of the rules to derive new knowledge from the knowledge base. So that is the job of the inference engine, and you have a user interface because the user is the one who is actually dealing with the expert system finally, right? And saying that this is I mean, whatever information the user gives into the system, it takes that information. For example, for a patient, you may give in all the lab tests that have been done, all the results of the lab tests, all the tests that have been done, you give in all the results, and it will give you a diagnosis on whether the person has cancer or not, etc. So that is the interaction of the system with the user. And you have a person who actually maintains the knowledge base. Okay, and also you have to first of all develop the knowledge base. So the knowledge base is developed from scratch by talking to an expert and getting information from the expert and putting it into the knowledge base. So the knowledge base basically consists of facts and rules, and the rules are conditional statements. If this is true, then, so if then rules. Okay, so there are a lot of if then rules in the expert system basically. And what is the type of reasoning you can have? Forward chaining, backward chaining, and you can also use the fuzzy logic where it allows shades of gray, so you have even uncertainty. When there's uncertainty you can use. Okay, so you can say that this is true with some particular probability or some confidence, etc. So that's a fuzzy logic. Backward chaining. Backward chaining, like I said, Prolog uses backward chaining. We have already seen when we carried out inference in predicate logic what is backward chaining, what is forward chaining. But to go back to it again, the backward chaining is starting from the goal, right, and going backwards and saying that okay, this is the goal, if this has to be true then all these predicates have to be true, and then you check in the knowledge base if all the predicates are true. If all the predicates are true, then you say your conclusion is true, etc. And forward chaining starts from your knowledge base and goes forward and tries to see whether it concludes what you are trying to find. Okay, so these are different types of reasoning which can be used. So first of all, the knowledge acquisition has to be carried out. So you must have a person who transfers the knowledge from the human expert to the computer. Or you can have a program, for example, some machine learning algorithms, neural networks, etc., which acquires the knowledge automatically and enters it into the system. Then you need to have method of representation of this knowledge. Okay, we know that you know how vast knowledge is, right? So how do we represent it in the system? That is suitable way of storing this information, of representing and storing this information in the computer. Then inference. So what is the mechanism that is used for carrying out the inference? And then the explanation. Okay, so it has to give explanation of its diagnosis or whatever it predicts, right? Why was that particular solution generated? It needs to give the explanation for that basically. So what you have is what is called a knowledge engineer. So the knowledge engineer basically acquires the domain knowledge from the expert and builds it into the knowledge base. So knowledge extraction, how can it be done? He has to talk to the expert, interview the expert, observe when the expert is working, okay, evaluation of the material used by the expert, use all these things and extract the knowledge from that. So this is what is known as the knowledge extraction or the knowledge acquisition which is done. Okay, and then it puts it into the knowledge base of the expert system in the form of facts, theories, rules, procedures, guidelines. Okay, so some heuristics which the expert uses and some strategies or approaches that can be used, and meta knowledge. Okay, so we have seen what meta knowledge is, knowledge about the knowledge which is there, right? Maybe you can say this is this knowledge has more importance than the other knowledge, etc., right? So that type of information. So that is the meta knowledge. So it uses all these to put information into the knowledge base, and this is what is called knowledge acquisition. It involves problem definition, implementation and refinement, as well as representing facts and relations as acquired from an expert. So you have the knowledge source, usually a domain expert, maybe other sources also, maybe some books, other sources, internet, etc. So he uses all these different knowledge sources, acquires the information, and then forms the knowledge base by using representation, transformation of the knowledge, etc. And this knowledge base is put into your expert system basically. So this is what the knowledge engineer basically does. And this entire process is known as a knowledge engineering. So the knowledge engineer mediates between the expert and the knowledge base, because the expert can only give the information. Okay, so that coding of that information into the knowledge base will have to be done by a person who knows something about computers, something about knowledge bases, how to put information into the knowledge base, etc. Okay. So the knowledge engineer elicits the knowledge from the expert, refines it in conjunction with the expert, and represents the knowledge in the knowledge base using some knowledge structures, right? He may have to see what type of knowledge structures to use. Does it involve time? Does it involve space? So what are the different possible ontologies that he can use, and how to code this information in the knowledge base? Is there uncertainty? If there is uncertainty, do I use probability, or do I use some confidence factors, etc., and how do I combine these, etc. Okay, so all these type of jobs are done by the knowledge engineer basically. Okay, so what are the components of this knowledge? Like I said, first you have the facts. Okay, milk is white, all crows are black, and things of that sort. Okay, so those are all facts. Siblings, Jane, John, and things of that sort. Those are all the facts. Then you have the rules. Okay, so you have rules which are used, right? Always check the traffic before merging into the freeway, etc. So that is a rule which you are putting into the system. And then you have the heuristic rules, which are the rules of thumb, okay, which is gained by experience. So the expert will give the rules of thumb which they use, okay, and they code those also into the system, maybe in the form of rules. Okay, so this gives some of the expert systems which were developed. So it started somewhere around 1960, and you had program called Dendral in Stanford, which identifies the chemical constituents of some substances, right? Then you have the Mycin. So Mycin was one of the earlier expert systems, again in Stanford, for the diagnosis of infectious diseases. Then MIT had one math expert system, and you had something called hearsay in CMU for speech recognition, and you had the prospector, which tries to see the mineral diagnosis in the earth, right, and see if is there any prospect of getting some minerals in some particular spot, right. So that again is Stanford. Then you have XCon for computer configuration. So this was very heavily used, okay, the XCon at that particular point in time. So Dendral is to deduce the likely molecular structure of organic chemical compounds. Mycin, diagnosis of infectious diseases, blood diseases, and recommendations for use of antibiotics. Then you have the prospector, analysis of geological data for minerals. Discovered a mineral deposit worth $100 million, right? So it was worth it, that particular expert system. And XCon, okay, or R1, which was used for configuration of DEC wax computer systems. So of course now these computer systems are not used, but at that time it was used to configure according to what the user actually wanted. Okay, and it had 2,500 rules and it processed 80,000 orders and saved DEC $25 million a year. Okay, so it was really very useful. Then you had the cancer decision support tool and PXDES, which determines the type and severity of lung cancer. DEXPLAIN, clinical support system that diagnoses various diseases. So these were some of the earliest expert systems which were used. So what are the different elements of the expert system? The knowledge base, the inference engine, the working memory. So that's the place where all the inference actually goes on. And you have the agenda, which is part of your inference engine, explanation facility, knowledge acquisition facility, and user interface. So these are the various elements or parts of your expert system which you are using. So you have something like the inference engine, which gets all its information from the knowledge base, and you have the working memory here, which is made use of by the inference engine, and the knowledge acquisition facility, which actually interacts with the user to get the knowledge which is required. And you also have the explanation facility, which the inference engine will give and is given out to the user basically. So these are all the elements of your expert system. So these are all the people that are involved in this. So first of all, you have the human expert and you have the knowledge engineer, and the knowledge engineer will interact with the human expert, and then the knowledge engineer actually makes the knowledge base, and that knowledge base along with the inference engine and the interface is your actual expert system, and the user is there. The user actually interacts with this system to get whatever information he wants from the system. So this is how the expert system actually works. So like I said, you have the user interface, the mechanism by which the user and the expert system communicate. Then you have the explanation facility, explains the reasoning of the system. Working memory, a database of facts used by the rules. And the inference engine, which makes the inferences by deciding which rules are satisfied by facts or objects, prioritize the satisfied rules, and executes the rule with the highest priority. So you may find that there's more than one rule which fires at a particular time. So when you say that the rule fires, it means that the rule is satisfied, the left hand side of the rule is satisfied. So you decide which rule is the one you are going to use, the rule with the highest priority at any particular point in time. That's the one which is going to fire at a particular time, and that will decide what is the diagnosis you are going to give or what is the prediction you are going to make. And then you have the agenda, which is a part of the inference engine, which gives a prioritized list of rules created by the inference engine whose patterns are satisfied by facts or objects in the working memory, right? And then you have the knowledge acquisition facility, an automatic way for the user to enter knowledge into the system rather than by having the knowledge engineer explicitly code the knowledge. Okay, so it's also possible for the user to enter some amount of information through the knowledge acquisition facility. So all this together forms your expert system basically. Okay, now we come to one type of expert system, which is the Mycin. Okay, so why I'm talking about the Mycin is that it's just like a example of an expert system which was used. So there were like 500 rules acquired from experts by interviewing, blood disease diagnosis. So one of the rules are like this. If stain of the organism is gram negative and morphology is rod and aerobicity is aerobic, then you have what is called 0.8 confidence that the organism is entero bacteriosis. Okay, so this is an example of a rule in the mycin. So if the stain of the organism is gram negative and the morphology of the organism is rod and the aerobicity of the organism is gram anaerobic, then there is strong evidence that the class is so and so. And this is how it comes in the Mycin format, right? So you conclude that it is this with a tally of zero 0.8. So this is the what is called the confidence factor. So we'll see what these factors actually mean. Okay, so this is another example of a rule in Mycin. So it uses what are called the certainty factors for all the rules to handle the uncertainty. So it's called as the degree of belief. So how much belief do you have in this particular inference? So you use what is called the measure of belief and the measure of disbelief, and you are going to take the measure of belief and measure of disbelief and combine them together to get what is called the confidence factor. Okay. So confidence factor is the measure of belief minus the measure of disbelief, and the whole thing depends on the probability of the hypothesis. Okay. So a particular hypothesis which you are using, what is the probability of that hypothesis? Okay, so we'll continue from this point in the next session. I'll stop the session here.